Systicon are experts in producing world-leading logistics software. The tool suite includes CATLOC. CATLOC accommodates all the primary uses of lifecycle costing, or LCC for short. As different uses may require different LCC models, CATLOC allows the LCC model to be defined by the user. This allows the cost breakdown to follow a predefined standard model, or for the user to specify their own. This demonstration describes the results and reporting capabilities of CATLOC. Once run, CATLOC presents the result window. Here the LCC is shown. If additional models are run, their results will be shown on the same chart. This allows comparisons to be easily carried out, and in this example some parameters in Demo 2 have been changed. We'll now identify where the differences are, but note that the same actions can be used on a single set of results as well. First, we will just zoom in so that we can see the differences more clearly. To identify where the differences are, we could first take a look at where in the cost model the different costs are assigned. In CATLOC, it is simply a case of dragging the required dimension onto an axis and drilling into the model. So we can drag the cost dimension onto the y-axis. At first, no difference is noted. Now, open the cost dimension and select the basic view. That's the view that was defined in the cost structure table of the input file for this model. Of course, it might be that more than one cost breakdown structure has been defined, and if that were the case, then they would all be listed here. Note also that because we have two models loaded, the possibilities for each may differ. But in this example, both models have the same cost structure. Now we can expand the cost model. Simply by expanding the LCC by one level, the chart will be updated when the options are closed. On the chart, we now see all the top-level costs of the LCC tree. In this layout, it is not clear which costs differ, so let's move the cost dimension to the x-axis. Now we can compare directly the different cost elements. We can also adjust the way the chart is presented, simply by adjusting the order of the case and cost dimensions. We can see clearly that the difference between cases is due only to the LCCA, or acquisition costs. This can be identified if we hover over the chart legend. We can drill down further to see where the differences are. This is simply a case of restricting the cost model to the LCCA. Again, this is done by opening the cost dimension and selecting the LCCA cost aggregate. We might as well expand it at the same time. Now the chart is only comparing the cost atom CAS, which in this model is all that contributes to the LCCA. In this example, it doesn't really tell us much, but if the cost model was more detailed, and it could be amended to be so, we would be able to continue the process of drilling deeper into the cost model. So we now know that the difference in the cost is attributable to the LCCA. Let's identify why this is the case. Firstly, in this cost model, the LCCA is only attributable to systems, which in turn are deployed at stations. So we would expect to be able to identify which system contributes most to the LCCA, and at which station they are deployed. We'll start by looking at the system element. By adding the system dimension to the x-axis and arranging the order of the dimensions, we can quickly see that the acquisition costs for each system vary in some way. Why could this be? Well, if we look at the cost model, we can see that the CAS, or system acquisition costs, are derived from the NRBD, or number of systems deployed at a station, and the equipment price. If we arrange the input files so that we can compare them and use the parameter view, we can see that in the models the NRBDs differ for each system. price is available for all items and systems in the material dimension, so it's better if we restrict it to the system domain only. Now we can see that the system prices are unchanged between models. So the differences between the models is entirely down to the different system deployments. If this was a genuine case, then it is probably more appropriate to say that if the deployments changed in this way, then the impact on the LCC would be as we have seen. Let's investigate these different costs in relation to the stations. By first removing the material dimension and then dropping the station onto the x-axis, we can see how the CAS is distributed between stations. Most stations show differences. Let's focus our attention on Op-S. Again, we can simply select the station dimension and restrict the stations shown by selecting the appropriate one from the tree. Now let's identify which systems at this station contribute most to the costs. Clearly, the system HCP43 contributes most. By moving the station to the Z-axis, we could actually produce a chart that shows only one station at a time, and simply toggle through each station. CATLOC allows sensitivity analysis to be carried out as well. For example, consider a case where the storage cost per unit could be twice that of the quoted figure. In CATLOC, simply add and populate the sensitivity analysis table with the appropriate information, and select the sensitivity analysis run. The result is the ability to compare the impact of the changes with that of the original solution. The model can then be analysed in the same way as that already discussed. Any charts generated can be saved for later use or inclusion in a report. Likewise, all can be copied and pasted directly into another Windows program, such as Word or Excel. Finally, CATLOC also provides a detailed reporting capability. In addition to saved charts, a full breakdown of the cost model can also be included. Report objects can be printed, exported, or copied and pasted to external programs. It's important to note that this is merely an overview of the model, and many features have not been covered. For more information about our tools, please select another demonstration. Or for more detailed information about our products, please contact us or visit our website at www.sisticon.co.uk.